Hey everyone, this is the third tutorial video for CU Hackett's upcoming freshman hackathon, Hello World. It's an awesome, totally free event, and if you're interested in signing up or want more information, check out our website, cuhack.it. Also, if you refer friends, like to join your team, you can get bonus swag and prizes. Happy hacking!
So we should be live. So hello everyone and welcome to my Hello World 2020 workshop. Today I'm going to be doing a quick introduction on how to use requests with Python. For all intents and purposes, I want you to think of requests as a way of interacting with web pages through programs rather than opening a browser and navigating to a URL. I'm going to operate under the assumption that those watching this tutorial have Python 3.6 or newer installed and have the corresponding pip. If you do not know what these things are, or you don't have them installed, there are tons of quick tutorials out there so that you can get everything installed and set up. Quick note, the code for this project is going to be posted in the description of the video, so you can follow along or just run my code and then break things and see how it works. So without further ado, let's jump in. The first thing we're going to want to do is download the necessary modules that we're going to need in order to send requests. For those unfamiliar, a module is just a Python program or package of programs that people have made so that their functionality is readily accessible to other people. So I'm going to go down here into my terminal, and this is just the terminal add-on for Atom, just so that way I don't have to open a terminal in a separate window. I can have it in the same space. So we're going to go down here and we're going to pip install requests. All right, already satisfied because I already had requests installed. We're also going to install another module called BS4, and that stands for Beautiful Soup 4. Requests is going to allow us to request information from locations on the internet given some form of address, and in this case, probably a URL. And Beautiful Soup 4 is going to allow us to easily parse the information that is returned from the request such that we can isolate parts of the response that we're interested in. So now that we have these modules installed, the next thing that we're going to want to do is make our empty Python file. So I'm going to call it first request.py there. And so it's going to open this first request.py. I'm going to save it. You'll see it show up in our Hello World repo over here on the side. If you don't know what that means, don't worry about it. So we're going to make a variable called response. And response is going to be the response when you request a given URL address. So for this example, we're just going to request google.com, and we're going to want to print that response and see. Please play nice. And see what that response was. So we're going to go ahead and run this. Response 200. Fantastic. So if the response is 200, that means that the request has gone through successfully. You can get other status codes as well. So you could get like an error 404. I'm sure that's the one most people are familiar with, and that just means it couldn't find the page that it had requested. You could get a 500 error. All we care about right now is that this was 200, meaning that the request went through successfully. So we're going to want to print the content of this request because it's nice to know what the status code is, but we're actually in this for the content. So I'm going to run that again. And you see here, all right, so as we can see, that is a heap of text. And if you take a closer look, you'll see that it's actually the HTML of the google.com webpage. By requesting the URL, similar to the way that your browser operates, we returned HTML. And if we check the response.content, the type, and if we check the type of response.content, so we can say print type of response.content there, and run it. It's bytes. So we have been returned the bytes of the raw HTML that make up the google.com webpage. Unfortunately, it's very difficult to make sense of the HTML that's been returned in this form. And so to remedy this, somebody wrote a module called BS4, or Beautiful Soup 4. So we're going to go ahead and from Beautiful Soup 4, we're going to import Beautiful Soup. And we'll go ahead and delete this for now and just see if everything ran. Okay, so that ran successfully, meaning that we imported Beautiful Soup. So we're going to clear here. And the next thing that we need to do is make a Beautiful Soup object. So we're going to call that object soup, and it is going to equal the Beautiful Soup of, and then we're going to ingest the response.content there. So we're going to say ingest this content and turn it into one of your Beautiful Soup objects. And we're also going to put another argument here. And this is just going to prepare Beautiful Soup that it is about to be ingesting HTML and that it needs to parse HTML. And then we're going to print soup.prettify. And so a soup object has this cool method that will take that heap of text and print it out the way you would see it in a regular HTML file. And so let's try and run that. And so we see here that this is now the formatted HTML of the web page, which is kind of cool because now it's going to be a lot easier for us to go through a web page and pick out things that we want. So for this example, we're not actually going to be doing the Google web page. So for this example, we are going to request the Wikipedia page of Ruth Bader Ginsburg. And I want to go ahead and run this program again, but with Ruth Bader Ginsburg's page, so that way we know that it's getting it correctly and it printed out the HTML, so we know that that request was made successfully. Really quick side note for everybody, I need to disclaim that you should check and make sure if it is okay to send requests to a website with a program before you do it. Most sites allow it, but there are guidelines to make sure that you aren't going around and accidentally breaking people's stuff, because people on the internet don't like that when you break their stuff. Wikipedia is perfectly capable and willing to accept programmatic access of their website. The only thing that they ask is that the requests don't exceed more than 60 requests in a minute. This is just to make sure that we don't accidentally overload the whole free knowledge for all mankind people's website, because they're nice and they don't deserve that. So we're just going to make sure that we don't send too many of these requests, because then it's going to make some sysadmin somewhere super upset. So let's not do that. So we got the HTML successfully. Now let's get something interesting from it. So let us get all of the links that are on this page. So we request Ruth Bader Ginsburg's Wikipedia page and store it in a variable called response. We ingest the response content into a Beautiful Soup object and specify that it's going to be parsing HTML. And now we want to pull all of the links from the web page. So the way we do this is we're going to make a list of links here called links, and it is going to be what soup.findAll. So soup has a find all method, and we're going to say we want everything that is contained in an A, because if we look here, oh, come on. So if we look here, we can see that all of the links on the page are contained with an anchor tag and href. So we want to go here and say find everything that is in a tag with href for header reference equals true. We're going to set that to true. And then we want to print links there. And we're going to save that. We're going to clear and then run our program. All right, sweet. So it gave us a super long list. Maybe there's a better way. Maybe let's print the length of links for now. Right there, Python 3. So we see here at the bottom, there were 2,576 links on this page. That's kind of cool. So let's take a closer look. So we want to go through, and for every link in our list of links, named links, we want to print that link and see what happens. So we run it, and we see it returns a bunch of stuff, and they're all contained in an anchor tag, and they have some text associated with them, some other settings, source. So all we really care about for a web crawler is going to be this href right here. So the link that is returned can actually be queried in dictionary syntax. So let's print everything that is the href inside of this link that is being printed there. Okay, so when we print the href that is in the anchor tag, we can see here that it gives us the entire URL that is contained in that anchor tag. And now that we've proven that, we can go ahead and we'll actually just delete that and just print the length of links again. So clear. Go run that one more time. Okay, so we have 2,576 links. And we could do the same thing again. We could maybe remake response, and now response equals request.get. But instead, we can say links, and then we can say the first element, and we want to do the href of it, because if we print this, there, it's going to print the link that it navigates to, and then it is going to get that at that URL, and then we want to print response and make sure that it went through. And then we get an error. Oh, okay. So this one is not a full URL, it's a URL extension. And so the easiest thing to do here is we are going to make a string called base URL, and we're going to say HTTPS, whatever the heck. We're going to say that, and we're going to say this. So this is our base URL. And so while it does just that, we need to append that to that. So let's get base URL plus links there, and it has a slash. So now it is going to, now let's print this. So this is the URL that it's actually getting now that we concatenate them. There. So it went to wikipedia.org/wiki/Wikipedia and good articles, and we can verify that that's a real page here. And so there was a link on Ruth Bader Ginsburg's page to good articles on Wikipedia. And so you can see how this is easily extensible. You could do something cool like iterate through this list of links and generate all of the URLs on it and then visit those, and you could map a website. Like I said, if you're going to try that, which I would even recommend, make sure that you are limiting the speed of which you are requesting Wikipedia's domain, or else they're going to get upset with you. Then they're going to have to IP ban you, and then everybody's sad. And that's not the goal of the hackathon. So yeah, just a quick little tutorial. I know it's not a lot of lines of code, but hopefully you consider this super powerful and maybe even get a cool idea for your hackathon today. So thank you for your time. If you have any questions, leave them in the comments below. So good luck, everybody, and happy hacking.